Welcome to ETM 260, Computer Aided Design. This is lecture 10, Introduction to Dimensioning. This video is complemented by the given PowerPoint. The dimensioning process is critical since it provides communication between the designer, the manufacturer, and the inspection steps in a production process. It must be clear and concise. We will go over some of the basic techniques needed to create a technical drawing. Let's start with the contour principle. This principle uses four main types of dimensions to describe an object: size, position, diameter, and radius. This must be properly used in order to provide all necessary details about the features on an object. The standards to create a technical drawing are based on the American National Standards Institute. Let's start with the units. The units are selected based on the function of the object and then by the manufacturing process. If you use in millimeters, precision is usually given by 0 or 1 decimal places. If you are using inches, precision is usually given by 1 or 2 decimal places. Let's now talk about the elements of dimensioning. The dimension line indicates the direction and the extent of the dimension. It usually ends in an arrowhead. The extension line is a thin, solid line that extends from a point of the object where the dimension is taken. Notice that there is always a visible gap between the object and the extension line. Let's now continue with arrowheads. The arrowheads are usually between the extension lines, if a space is available. The alternative choices are given when limited space. Notice that there can be different filling options for the arrowheads. Whichever one you select, make sure that you use exactly the same one for all the dimensions. These are some of the type of dimensions that you could use in a technical drawing. They could be linear distances, which can be horizontal, vertical, or aligned to a particular feature in the object. It could also be angles, to provide an angle between two lines or surfaces in a feature. In addition, a technical drawing can also have notes, which provide additional details about a feature. This table shows the most common symbols that are used in a technical drawing. If you notice, we have diameter, radius, reference dimension, contour bore hole, contour sink hole, the depth, and the number of times or places a feature is repeated. Let's now go over some of the issues you need to avoid when creating a drawing. In general, keep in mind that the drawing must be clear and easy to read. Here are some suggestions. Avoid conflicts, maintain some space between the dimensions, and do not use dimensions inside of the object. Let's do an example. What are the 6 dimensioning mistakes in this drawing? Let's start with the spacing between these two dimensions. Notice that it's not equal as the one that we have in here. The second, we need to remove the dimensions that are inside of an object. Notice then the text is intercepting this dimension over here, and also notice that the orientation of the text is not the same. We then see that there is no gap between the extension lines and the objects. And then notice that we do not have a dimension for the diameter. This will be the ending result and the correct dimensioning for that particular drawing. These are some other issues that you need to avoid. The dimensions should never cross any extension lines or other dimensions. The extension lines and center lines should never connect between views, and the leaders should always be straight at an angle between 30 to 60 degrees. Let's now go over this example. What are the 3-dimensional mistakes on this drawing? The first one that we see is that the leader, in this case, does not have an angle between 30 to 60. The second mistake that we see is that we have a center line that goes from the front view to the right view. And the third mistake that we see is that we have dimensions crossing extension lines. This is the final and corrected dimension for that particular example. Make sure to place the dimensions in such a way to enhance communication. Dimensions should be grouped when possible. Avoid dimensions between views, unless it promotes unclearness when placed outside. Do not dimension hidden lines, and do not duplicate dimensions. Let's do another example. What are the 4 dimensioning mistakes in this drawing? Let's just start by that this dimension is actually measuring a hidden dimension. In this case, these dimensions are better done when used in a group. In this case, we see that there is an extension line and a dimension line that are crossing. And in these different cases, we see that these dimensions are better represented in other views. This is the final and corrected dimension format for this particular drawing. Let's now talk about the circular and the rectangular views. Notice that these 2 views represent the same object. If you use a circular view, you provide the diameter and the position of the features. If you use a rectangular view, you provide the diameter, the length, or the depth of the features. In most cases, both views are required to provide the necessary information about an object. Let's now talk about some of the dimensioning features available. For example, if you have a repeated object or dimension, you can indicate so by using the X symbol and the number of repetitions. See in this example that all the circles are separated by the same angle, and all of them have the same diameter. We simply indicate that the distance between them by using 4x and the angle between them. And notice that we indicate that they have the same size by indicating 4x and the diameter value. If you're dimensioning a curve or a fillet, you may do so using any of the ways shown here. If the location of the radius it is important for your feature, a cross must be drawn at the center of the radius. If you are dimensioning an spherical component, you need to define using a diameter if it is complete or radius if it's incomplete. If you are dimensioning a hole, the most used form to indicate it is by using the diameter of the hole and the depth shown in this note over here. If the hole goes through all the feature, make sure that you add the abbreviation through after the dimension of the hole. If you're using symmetry, only dimension one side of the drawing. If you are dimensioning a counterbore hole, you need 2 different diameters, the counterbore diameter and the drill diameter. If you want to show the depth of each one of the holes, you may do so in 2 different ways. One, you could add a note to indicate the depth by using the depth symbol, as shown over here, or you could use an alternative view where you could show the depth of each one of the holes. This is the end of Lecture 10, Introduction to Dimensioning. Make sure that you complete all the required quizzes, review all the material given in the PowerPoint, and be ready to start Lecture 11, Dimensioning in NX.